everybody, welcome back to my YouTube channel. This is Hemashri, studying in Sri Venkateshwara College of Engineering, currently pursuing my second year BE in Electronics and Communication. Today in this video, I've come up with a subject Digital System Design using VERILOG. So today my topic is conversions of JK flip-flop to T and D flip-flop. So let's begin with the video. Starting with the introduction, a flip-flop is a basic building block of sequential digital circuits. It is a bistable multi-vibrator that can store a single bit of data, 0 or 1. Flip-flops are widely used for data storage, that is, they serve as memory elements in digital systems, and synchronization used in clocked circuits to ensure data transitions occur in a controlled manner. And the third state is to the state retention, vital for counters, registers, and finite state machines in digital systems. Then we have data transfer that facilitates communication between different parts of a digital circuit. Then the types of flip-flops are, and the common among them are SR flip-flop, D flip-flop, JK flip-flop, and T flip-flop. So SR flip-flop, it is a basic latch with set and reset inputs, and D flip-flop, that is a data or delay flip-flop which outputs the input after one clock pulse. And then we have JK flip-flop, versatile flip-flop, avoiding invalid states of SR. And then we have T flip-flop, nothing but toggles the output on each clock pulse. Now coming to the importance of converting JK flip-flop to T and D flip-flops. So the first important is simplification. Some designs require specific flip-flops like T or D due to simpler behavior and easier design implementation. And then for the compatibility, T and D flip-flops are commonly used in applications such as counters and shift registers requiring conversion from a JK flip-flop in existing designs. Then we have efficiency. The conversion helps optimize circuit designs, saving gates and simplifying the logic. The last thing is design flexibility. So it enables the use of a single flip-flop type, example JK, to mimic the behavior of reducing the need for different hardware components. Now let us know a few things about JK flip-flop. JK flip-flop is typically represented with the following symbol. It has two inputs J and K. It has one clock input and two outputs Q and Q bar. So from the below truth table of JK flip-flop, we can get to know that when J is equal to 0 and K is equal to 0, there is no change. Q retains its previous value and also the Q bar. And when J is equal to 0 and K is equal to 1, it is in reset state, and Q becomes 0 and Q bar becomes 1. And when J is equal to 1 and K is equal to 0, Q is in Q becomes 1 and Q bar becomes 0. So when both the J and K inputs are 1, the Q and Q bar switches between 1 and 0 with every clock pulse, and this stage is known as toggle stage. So let us move further. Now coming to the main part of the video, that is conversion of JK flip-flop to T flip-flop. Here the T flip-flop truth table is given. From that truth table we can understand that when T is equal to 0, the next state is same as the current state, there is no change. But when T is equal to 1, the next state is complement of the current state, that is it toggles. And then we have the excitation table for JK flip-flop. So this excitation table shows the required inputs of a JK flip-flop to achieve specific transitions. So this JK flip-flop helps JK flip-flop excitation table helps in converting JK flip-flop to T flip-flop. So here X represents the don't care condition, and when the current state is 0, there is no change with the next state, but with the same current state, when it is 0, it has another chance of the next state to become 1. Moving on. The next step is to relate the T flip-flop input to the required inputs of the JK flip-flop. Compare the T flip-flop truth table with the JK flip-flop excitation table. So this after this establish the conditions for J and K based on the value of T. So after comparing, we will get the truth table as shown here. And then for mapping this T flip-flop, we will get J is equal to T and K is equal to T. So here is the circuit diagram given for the conversion of JK flip-flop to T flip-flop, and this is the K map which has been uh, done to know the J and K values. Moving on. Now coming for the conversion of JK flip-flop to D flip-flop. Here there is a truth table that represents a D flip-flop, and the output Q, that is nothing but the next state, directly follows the input D after a clock pulse. And we have the excitation table for JK flip-flop, which helps in the conversion, and here X indicates a don't care condition. Now we will map between D and JK inputs. To map for that, we need to compare the D truth table with the JK excitation truth table. So from the table, we will get J is equal to D and K is equal to D bar. So here is the circuit diagram for conversion of JK flip-flop to D flip-flop, and this is the K map, which helps us to get to know what is J and K. So from this, uh, we will get to know how to convert JK flip-flop into T and D flip-flop. So hope you guys understood. Thank you for watching. Please do like, share and subscribe. Thank you.